Okay, now we're going to do quadratic inequalities. So when I solve a quadratic inequality, I'm going to set my equality as an equation so it equals 0. Now I'm going to try and factor it. If factoring doesn't work, you can always do the quadratic formula if you want, ABC. If I factor, I get x and x. Multiples of 8 are 2 and 4. 4 is positive, 2 is negative. X minus 2 has to equal 0. When I move it over, I have to add it to both sides. X equals a positive 2. So I had to move the 2 away from the x, it became a positive 2. If I had to move the 4 away, then the x would equal a negative 4. I'm going to place those on my number line. Negative 4 goes on the left, positive numbers go on the right. My dot is going to be closed because it's equal to these numbers. Now I check. I like to plug in 0 to see if I'm going to shade here. So by plugging in 0 to my original equation, I'm going to get 0 squared plus 2 times 0 minus 8 is less than or equal to 0. 0 squared is 0. 2 times 0 is 0. Is negative 8 less than 0? Yes, that's true. So then because it says yes for 0, that means if I ask myself, do I shade here? Yes, I shade in the middle. So we are going to have negative 4 all the way to 2. Oops. And because of the closed dots, you need brackets. There we go. On problem 13, you can either do the quadratic formula and find your x values for your number line, or you can try and factor. I'm going to factor out a 2 because it goes into 12 and 16. So half of 12 is 6, half of 16 is 8. Then I can factor it even more. X breaks up to x times x. Multiples of 8 are 4 and 2. I need a negative 6, so they're both negative. When I solve this, the 2 in front, the common factor, does not have an x, so it will not equal 0. X minus 4 will equal 0, so I move the 4 over and get positive 4 and a positive 2. If I test 0 on this one, it's on the left side, it's on the outside. So let's check it. 2 times 0 squared minus 12 times 0 plus 16 is greater than 0. 2 times 0 squared is 0. Negative 12 times 0 is 0. 16 is greater than 0 is true. So yes. That means when I ask myself, do I shade where the 0 is? Yes. And with the quadratic, because it is a parabola, if the left side is greater than 0, that means that the right side is also greater than 0. My points on the 2 and 4 need to be open dots. So let's check. Over here is negative infinity, positive. Negative infinity all the way to 2. Then there's a space, so we use the union of 4 all the way to positive infinity. 14. I can't factor this one, so A, B, C. I'm going to use quadratic. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Negative 4 plus or minus square root b squared minus 4ac all over 2a. So we get two negatives make a positive 4. I simplify the inside and it becomes 24 over 4. I'm going to write the square root 24 as a decimal. for my number line. So I'm going to get two solutions. I'm going to get a negative 0.2 and I'm going to get a positive 2.2. When I do 4 plus 4.9 divided by 4 and 4 minus 4.9 divided by 4, that's how I get my two solutions. The dots are going to be open and zeros in the middle, so I'm going to check it. If I plug in 0, gone, gone. Negative 1 is less than 0 is true. Yes, true, so I shade the center. Negative 0.2 all the way to 2.2. Alright, let's double check. Alright, 15. I'm going to try and get all of my terms to the right side. So we have 2x squared minus 10x. If I move the 25 over, it becomes a positive. If I move the x squared over, it becomes a negative. I want to combine like terms. Try and factor it. Multiples of 25 are 5 times 5, and to get negative 10, they both have to be negatives. That way my solutions are 5 and 5, which means I can only mark one spot on this graph, and it's going to have an open dot. Then I check where I'm going to shade, so I'm going to plug in a 0, and I'm going to plug in a 6 to see if it's alright to shade the sides. So I have 2 times 0 squared minus 10 times 0, negative 25 plus 0 squared. 0 squared is gone, gone, gone. Is 0 greater than negative 25? True, 0 is greater than negative 25, so I shade where the 0 is. Plug in a 6. 6 squared. So then we get, is 12 greater than 11? That's true. So we also shade the right. That is negative infinity all the way to 5, and 5 to positive infinity.